Yeah, oh, hello.
Yeah, I would recommend you start, and everyone please post questions in the chat or directly after the talk. Thank you.
Okay, thanks a lot. So firstly, yeah, as Ella introduced, this is essentially sort of trying to predict or use NLP to recover useful features that we can use to predict COVID caseload in specific regional areas. So there were three or four, sorry, fundamental objectives that we had with this project. One was to show that it was a viable task, and to show that there could be some link that was made between Reddit data and the COVID caseload in a geographically specific area. The other was to try and create a sort of somewhat unsupervised means of doing so, as the current processes, the current methods involve some sort of subjective and a priori selection of features. And then the other is to actually not only show this is a viable task, but also show this is actually a pretty good place to start, and actually that looking at Reddit data is a good data set and can result in some good features. And then finally, it was to show that this could be applicable across different regions. So as I mentioned earlier, those sort of, as I just mentioned, you know, within the prior work, and I've chosen to select one paper in particular, which sort of characterizes the current state of affairs, is that generally the current method is to select a priori words that feel informative to us. And so within this paper, influenza was selected, or the Greek words for influenza, and they were essentially used within an autoregressive model to predict the caseload, and that was compared against the Google search data as well. But the difficulties with this, and the difficulties with applying something like this with to COVID-19, is that at the beginning of the pandemic, as I'm sure we all are aware, is that not both the population knowledge about the subject and the population language about it was in huge flux. You know, we were learning different things about it, and we were speaking about it in different ways. So I think in order to, you're essentially assuming a steady state when you select one word and try and essentially use that for the whole of your predictive window, or the whole of your predictive time slice. So yeah, we wanted to move away from this and select sort of some overrepresented words within the subreddits. A general pipeline, and this is you know, I've included the main blocks that are used in this this project. Fundamentally, firstly, download the data and process it into a sort of meaningful format, and then from there I wanted to identify overrepresented words within the subreddit, and we did this. I'll go into further into how we did this in the following slide, but we just did this in comparing it to the rest of Reddit and how people were speaking on the rest of Reddit at that time. And then from there we did some, you know, we essentially used these the level of overrepresentation to select some features or individual words. And then we just combine this with our control data sets, and after a bit of you know, formatting, we inputted this into the classification model. And this classification model was aiming to determine whether a particular data point, a particular day, exceeded a sort of certain threshold increase in the COVID caseload or not. And so, and that is roughly how the model works. The sort of the feature selection, we firstly went around identifying overrepresented words, and so how we created a reference corpus of the rest of Reddit within the sort of window that we were looking at. So we took the subreddit that we were looking at. So in this case, in the diagram, we can see in the bottom right-hand corner, that's the Washington subreddit, and we essentially just randomly selected a comment, and then downloaded the next 100 comments from the rest of Reddit that were posted, and we just did this until we had the same number of comments within our reference corpus and our subreddit. And then we basically just used the term frequency to determine the top 50 words, top 50 most overrepresented words. But this resulted in a lot of very unique and rare features. Some that perhaps were just too sparse really for use. So we also selected the top 50 from the top 1,000 words, so that words like COVID-19 could come through into our model. As you can imagine, COVID was also spoken about a lot on the rest of Reddit during this window. So, and then following that, once we had the top 100 words, we just used a chi-squared test to reduce that further down to 50, so that we had a little less noise within our features. Now I've included the sort of the 25 feature words that our model arrived on, that were used as sort of features within this prediction, and these are in the 4 states that we tested through this paper. And you can see there's sort of some categorization within that. You've got locations, people, organizations, somewhat technical epidemiological words, and then just other more semantic, just interesting different words that can't really be categorized. We can come back to this slide if people want to at the end. And then we wanted to also compare, as I said earlier, we wanted to compare to some control data sets. So one of the ones that we used was the Oxford COVID-19 government response tracker, which has essentially 3 categories of policies that it looks at. You've got containment policies, economic policies, and health system policies. And within that, you have different measures, and they have overall category indexes. And above and beyond that, when you combine all 3 policies, they give you a overall government response stringency score that we can use to sort of determine roughly what the government's doing in that specific area. And that goes down to a really geographically specific region, so we can go down to the state on that level. And we also use the Google COVID-19 community response, community mobility reports, and this essentially just looks at what the movement was like within different areas around a state, and it just compared the movement to a benchmark that was made in January of 2020. And finding what we were actually trying to predict, we went with the 7-day moving average, as I'm sure you're not surprised about. That we just wanted to remove any periodic artifacts that resulted from the different testing regimes on different days of the week. In combination with that, we also used a 7-day average for the features, for the word features. Purely because people do talk about different things on different days of the week. So we wanted some, we just wanted to remove all artifacts that could result from using different days of the week. So for the majority, well, for all of our features, we've done a 7-day moving average. As a result, we haven't, the minimum prediction horizon is 7 days, so that we don't, there's no leakage. So further to defining our prediction horizon, prediction target, we've used essentially thresholds, which then we can then label our data points with a binary value of a 1 or a 0 as to whether the COVID case, the caseload exceeded that threshold within that time, within that prediction horizon. So we've used both relative and absolute as a sort of somewhat comparison to see exactly what different feature sets perform, if they perform differently, and we wanted to vary the threshold so that we saw if there was a difference in sort of feature weighting within more epidemiologically extreme events. The results sort of summarized best on this page, and this breaks down the results both into a relative threshold and an absolute threshold, and breaks them down within each feature type. So the T subscript W is the subreddit data, and the M is movement, G is government response, and P is actually the post count, just the post count, and the CCL is the current caseload. And within all of these cases, that just that individual feature is used to predict the prediction target. And what we can see is that actually the performance of the relative threshold is tied, and the subreddit data is performing very well, and is performing even better actually an absolute threshold. And also what we're seeing is, somewhat expectantly, when we combine them all, we're seeing the highest performance generally. Moving along to the sort of feature selection of the model. We're seeing that actually the model really weights the subreddit features and does value their importance within that. Now there's some feature importance within a random forest model. There can be some bias, but it's pretty interesting to see that there's quite a high weighting of subreddit data when we combine all feature types and all data sources. Moving over to generalizing these results across multiple regions, we see that actually the pattern that we saw in the Washington subreddit, and apologies, the prior two slides were done on the Washington subreddit. We can see that these results are also carried over to the California, Texas, and Florida subreddits. Now, this data is sort of summed up in a slightly different way. I've compared the subreddit data to the not Reddit data, and that is the NR. So we can see that the not Reddit data, when all of them are combined, they actually perform better than the subreddit data within the 14 and 21 prediction horizon, but the subreddit data performs better at the 7-day horizon. Now, I think this is somewhat expected. There's a significant amount of complementary information within the movement data and the government response data. But what we can see further to this is that when we actually combine the subreddit data to the not Reddit data, there's a further increase in performance. And it shows that actually there is complementary information within the subreddit data that we're not seeing come through within the movement data or the government response data. And we're seeing that in multiple states. So just to sort of conclude, and just to sort of link back to the introductory slide, we wanted to show this was a viable task. We did that. We've done this in a way that doesn't rely on any a priori sort of beliefs that we think that influenza is going to be a good word or COVID-19 is going to be a good word that will predict caseloads to increase. And we've showed that actually it performs pretty well in comparison to the other control data sets. Not only that, a point which is important to make is that the subreddit data, we have access to it instantaneously, whereas the update speed of the Google mobility reports is between 2 to 3 days, and the government response data is 1 or 2 days. But so we're seeing, this is instantly accessible data, which I think has to benefit the quality or benefit the usability of the data even further. And the final thing is we showed that this could be generalized across different regions. Just to quickly touch upon the work that we've done since this paper, we've introduced a sort of embedding topic model, which instead of tracking words can track topics and concepts within the subreddit. So we've used a sort of a clustering of the embedding space, which can define our topics that we aim to track through. And I've included the reference papers which we've used, and I've also included some of the topics that we found as a result of this clustering technique that we used. And these topics we use as our predictive features. So that's really where the project's gone since then, but ultimately this is, that's it. If there are any questions,
Thank you very much, Felix. Have you got any questions? Please maybe show your face if you would like to speak directly. So from my perspective, I'm still waiting for other people to ask questions. So you think your feeling is that we have immediate feedback on things happening from Reddit, yeah?
Well, we can download it instantaneously. While the we are bucketing them within days. So I suppose there's an element to which you probably you need to wait for the full day of data, but there's no delays beyond that. You know that this, once you've got a full day of data, you can calculate the prediction.
Mm-hmm. Okay, and what is the kind of correlation between what people write there and what the actual facts are? Like if a week later you'll get the government data and all this, so you actually can only do the assessment of truth with some delay. What is the best correlation you can expect from this? Because numbers are numbers, and here you've got people saying things, so there could be potential disparities because of the approach.
Sorry, so there's I didn't quite understand the question.
Well, for me, like from the philosophical point of view, you have got people here talking about stuff, so it's like you go to a pub and you exchange opinions with your pals. Yeah. And on the other hand, you've got the numbers coming from objective sources. So which ones, should convince us more?
Well, look, I do think there is a potential for quite a lot of noise within this data. But I think some combination is undoubtedly the best. Like we have tested this this within a sort of a real-time setting. So the majority of this is done, well, all of this is done in a sort of somewhat randomized test train split. But we've seen good performance actually when we've held out data and just tested it on purely historical data. So while yes, there will be noise, there will be some meaningless stuff that people just talk about, nothing to do with COVID. But I do think that by seeing that improvement in performance, there we can see that there is actually some value that they're adding, and some value that some of these features are contributing to the prediction. But yeah, you know what you're seeing when you see the other data. So no, I get that point.
No, I'm just wondering, because it's like, one thing is listening on the grapevine, seeing what the people are chatting about. Yeah. And there's also certain coloring, but you get to know, basically the bottom line from your presentation is that we get to know things faster.
We get to know things faster, and equally there is an improvement when we use it. So while the improvement isn't monumental, and I think we should probably be cautious in expecting a monumental improvement. I don't think that's realistic, but I think that we are seeing a consistent improvement, and we're seeing that across different regions. So there is some usability within this, but I do think that there is noise that is added within this method, but I still see value in it, and seeing that just the words, just the individual feature set of just the words performing so well in comparison to just the movement data or just the government response data shows that there is some value within this data.
Mm-hmm. Yeah, that's very interesting. So you went through a lot of detail very, very fast.
Sorry, apologies.
Yeah. No, that's all right, because we've got a time limit. But on the other hand, I was thinking, like, what kind of features in your head, like what are the most important features? If I was to do this exercise after you've done it and redo it with some, how would you approach could you give us advice on feature engineering, your experience from the perspective of feature engineering of this?
So one thing we were seeing is that the reason why we use the chi-squared test to reduce the features further is that that these features are noisy and there are a lot of them, and sometimes they're not that useful. So I think you don't want a large amount of features. You want to reduce them down to a manageable level. We saw pretty poor generalization when using a large number of features, because the model essentially you want to condense the features down. Mm-hmm. The interesting thing is that we've seen sort of some similarities between the model that we've subsequently produced and this this model presented in this paper. Is we've actually seen some consistency within the features that they both select. So I think that's pretty it's pretty good for the consistency, I suppose, of the methods, and shows that there is something consistent within the data that they're finding, that two methods can find similar features. But yeah, the features that it comes down on mainly in this is the locations. So there's a lot of talk about hospitals, and that's a informative feature within this task. Yeah. Okay,
thank you. And could you tell us maybe about the implementation? Did you implement this? What kind of software did you use to implement all this?
So I use Python, just the PyCharm text editor. Yeah, I just used my computer, so this wasn't done with any sort of clustering things. The other model did use sort of the Oxford cluster, so because it was using the transformer-based models. So, but this model you can do on your computer.
That sounds very good. Are there any questions from the audience? Okay, in that case, Felix, thank you very much, and good luck with your exams. And see you at the next conference, or maybe during the break.
Yeah, no, definitely. Okay,
thank you very much. Thank you. One piece of information for everyone: all the sessions are 10 minutes delayed. Did someone want to ask a question?
There is a question in the chat.
Oh, okay. So do you think we can reproduce the results using other social media, for instance, Twitter? This is from Susie.
So we did initially, when looking at this project, we did initially think about that. The real benefit of using Reddit within this task is that we have subreddits, and that sort of it means that we can assume, and this is an assumption, that when you're talking on a coronavirus Washington subreddit, you're talking about coronavirus in Washington. So I think this method is possible on Twitter, but there will have to be some sort of geolocation of the tweets, and there's significant literature on that. I'd say probably we came to the conclusion that the performance wasn't sufficient to transfer this to Twitter, but I think we're seeing results of geolocation as within the 70%. So as that improves, this might be applicable to Twitter, but I think you probably couldn't quite get it to the level of a state level. You'd probably have to be looking at the country-wide level, because I don't think geolocation is good enough at this point.
I see. Interesting. Because I missed the first 2 minutes of the talk. That's why I wanted to just confirm. You also checked with other social media data. Okay. Yeah. That's very interesting.
We didn't actually try it because we just thought it would bring in too much noise.
Yeah, it also struck me that subreddit data actually worked so well, because I mean, also Twitter data comes with a lot of noises. That's very true, and also people had a hard time filtering out the important keywords and stuff. So yeah, great work.
Yeah, there was a significant amount of cleaning at the beginning.
Exactly.
That is, I think, what you sign up to when you deal with social media data in any task.
Yeah. Thank you.
Yeah. Thanks. Thank you.
Thank you. Any other comments from anyone? Okay. Thank you very much. So we'll close the session, and all the best, Felix, and good luck. And maybe see you tomorrow.
Yeah.
Later on today. Thank you. Bye-bye.
Thank you. Bye.